Tsar bomber detonation altitude was 13,000 feet above the ground. This was the height estimated by the Soviet scientists to provide the maximum explosive damage while reducing fallout. The radio altimeter transmitted a signal to the ground and then measured the distance from the reflected signal. Its readings were verified by barometric sensors. If the data matched, the safety devices were deactivated. The primary fission charge was made from two spheres located in the weapon's forward and rear sections. Each sphere consisted of a shell of high-performance explosives with detonators, a beryllium inner casing, and a plutonium sphere around 4 to 6 inches in diameter at the core. A system of gas-filled spark gaps was connected to high-voltage capacitors, which were charged by a battery pack. When triggered, each spark gap closed to pass very large currents instantaneously, ensuring the detonators fired within 0.1 microseconds of each other. In that time, light would travel just 98 feet. A spherical shell of high-performance explosives, presumably octol, a mixture of octogen and TNT, exploded, creating a shockwave and causing compression inside the core. Once the plutonium had been compressed, it went supercritical and would start emitting vast amounts of neutrons. A neutron striking a plutonium nucleus caused it to split into two smaller nuclei, releasing energy and emitting additional neutrons. These neutrons went on to split other plutonium nuclei, launching a chain reaction. The beryllium inner casing reflected the neutrons back into the core, therefore increasing the efficiency of the primary stage and producing a stronger initial blast. The fission process generated an enormous amount of heat, reaching temperatures of 100 million degrees Celsius, several times higher than the core of the Sun. It released a massive pulse of high-energy gamma rays and X-rays, which was then used to trigger the secondary stage of the explosion. The second charge consisted of a lead outer casing, a layer of lithium deuteride, which was a compound of lithium, and the fusion fuel deuterium, and a plutonium rod in the center. The plutonium rod was compressed and subject to a barrage of neutrons released during the first stage. It made it turn supercritical to produce more neutrons. Lithium deuteride absorbed the neutrons and produced tritium, a radioactive isotope of hydrogen. Under extreme temperatures and pressures, deuterium and tritium nuclei collided and fused to form helium, producing an enormous amount of energy.